Alright, so in a particular car crash, an automobile of given mass collides with the wall and bounces back. Alright, so important key piece of information here, it bounces back. This is an elastic collision. So it goes in with one velocity, comes out with a second velocity. It does tell us the initial and final speeds are 14 and 3 respectively, but since we have two different directions here, it's important that we set our coordinate system. So this is our wall. It's going in with the speed of 14, but then it's bouncing back with a smaller speed of only 3. These are opposite directions, and so we need to make sure that we state the direction. So let's make to the right positive and to the left negative. So the initial velocity will be positive, the final negative. All right, if the collision lasts for a fraction of a second, find the magnitude of the impulse due to the collision. All right, so impulse, J, is equal to change in momentum. In this case, the variable that's changing our momentum is the velocity. So let's just go ahead and rewrite this as m delta v. We know the mass is 1277 in my case. And here's the important thing. Change in velocity is the final minus the initial. Now my final velocity is -3 minus the original velocity is 14, making my change in velocity equal to -17. So 1277 multiplied by -17. And we should get a big number for this. I'm getting -21,709. So impulse is in this case, we did kilograms times meters per second. So that's our unit. All right, so what's our answer? Well, the question is asking us for the magnitude of the impulse. Since it's asking for magnitude, it doesn't want the sign. So we're just putting in the number, not the direction. On to our next question. Here we're trying to figure out what is the average force. So since we already have impulse, we already know what J is, we can use that. And J is also equal to force times time. So to solve for force, that would be equal to J divided by T. Our J is our previous answer. In my case, -21,709. And we're going to divide by, it's a fraction of a second, so 0.13. So we should get a very large negative force. And my answer comes out to 992. So 166,992. That's in newtons. And just like what we did before, it's asking us for the magnitude. So we will not put in the negative, we are just putting in the number. Don't put in the comma. Just put in the numbers.